Welcome to Spring LIB.
In this question, given data is that is during a heavy rain, 2000 hailstone is striking on the roof. So the hailstone's diameter is given, that is dia is equal to 1 centimeter, and in the question it is saying that the number of hailstones is given, that is 2000 hailstones is striking on the roof, whose size is given in the question, that is 10 meter multiplied by 10 meter, and they are striking in perpendicular direction, that means vertically they are striking on the roof, and in the 1 second they are striking. And in the question it is saying that assume that the hailstones do not rebound, do not rebound. So we have to find out, that is average force exerted by the falling hailstones. So this is the question, and in the question the density of hailstone also given, that is density of hailstone is equal to 900 kg per meter cube. So here we have to find the average force which is exerted by hailstone when they are striking on the roof. So let's start answering this question. So in the answer, first I will write the dia of hailstone, that is given diameter, that is d is equal to 1 centimeter. So I can say that in meter it will be written as, that is 0.01 meter. So I can say that radius of hailstone will be equal to, that is r is equal to 0.005 meter. So in the question the speed of hailstone also given, that is when they are striking the speed is given with v is equal to, that is 20 meter per second. So at this speed the 2000 hailstones are striking on the roof. So I can say that the volume, after here finding the radius, the volume will be written as, that is volume of hailstone will be equal to, that is v is equal to 4 over 3 pi r cube. So use this formula for volume. So here substitute the data, then I will get the v, that is equal to 4 over 3 multiplied by pi r cube, means 0.005 whole cube. Now simplify it, then I will get the value, that is v is equal to, volume is equal to 5.235 multiplied by 10 to the power minus 7 meter cube. Now next step is I am trying to find mass of this hailstone. So mass of hailstone will be written as, for 2000 hailstone will be written as, that is number of hailstone, that will be, that is 2000 multiplied by volume multiplied by density. Volume will be, that is which I had get in the above step. So I can say that volume is, that is 5.235 times of 10 to the power minus 7 multiplied by density will be, that is in the question given density is, that is 900 kg per meter cube. So here I am writing the density, that is equal to 900. So now simplify it, then I will get the answer, that is mass of 2000 hailstone will be equal to 0.9 9422 kg. So now next step is, in the question the speed of hailstone is given, that is equal to v is equal to 20 meter per second. So I can say that the rate of change of momentum will be written as that is total mass multiplied by velocity. So that means I can say that 0.9422 multiplied by 20, that will be give, that is after solving I will get value, that is rate of change in momentum will be, Torque's value will be, that is 19 Newton per meter square. So after getting this value I can say that the total force exerted on the roof will be, that is equal to rate of change of momentum. So I can say that value will be, that is 19 Newton per meter square. 19 multiplied by total area of roof, that means area of roof is given in the question, that is 10 meter multiplied by 10 meter. So here I can say that multiply this area, so 10 multiplied by 10 will be, that is 100. So I can say that 1900 Newton. So that means the total force exerted on the roof will be, that is 1900 Newton. So this is the answer of given question. Thank you.